Hi there. In next few minutes, I'm going to show you what I have done in the last few months. My topic is building Chinese chatbot with controlled sentence function. Here are the contents that I want to cover today. To begin with, since our conversation model is built upon a controlled sentence function network, so what is sentence function? It is a linguistic terminology which refers to the speaker's purpose in speaking a specific sentence, a phrase, or clause. And in general, there are four types: declarative, interrogative, exclamative, and imperative. And as you can see in this table, there can be different responses for the same post, and each of them has different sentence function. For the interrogative, it is essentially a question and ending with a question mark. For the imperative, it is usually a request, like please help me something, usually ends with an exclamation mark or a period. For the exclamative response, it just demonstrates strong emotion of the speaker, and usually it will end with an exclamation mark. And some examples like what a smart guy, or what a good weather, and how smart you are. And for declarative response, it is just a statement ending with a period, and it will demonstrate the ideas of the speaker. During this project, we will not consider exclamative response, because we think that exclamative response is less meaningful than the other three responses. There are two challenges in training our model. First one is that we adopt global control structure, which means the model needs to learn the word orders, word patterns in a global scale for each sentence function. It is difficult in terms of achieving a similar accuracy as the local control structure does. And the second challenge is compatibility of controlling sentence functions and informative contents. If you control the sentence function of a response, sometimes it can be general or universal or meaningless sentences like I see, or so do I, or like please. Very simple response, but that is meaningless within a dialogue. We try to overcome these two challenges in our models. In this project, there are two objectives for our models. First, the model needs to implement a controlled sentence function, which means it can generate a response with respect to the sentence function. And meanwhile, we want the response to be informative. As for the resources we have, is listed as following. The word embedding scheme is constructed from Chinese news, Baidu Baike, and novels, and Chinese novels. Its data size is around 1 million, and which is 4 times than the ordinary modern Chinese dictionary. So I think this would be enough to convert the hot vectors into embedding vectors. And for the dataset, it's retrieved from a professor at Tsinghua University. He constructed this 2 million labeled Weibo post response pairs. And for the conversation model, it is referred to a paper in 2018. In the implementation level, I created 2 applications to build the chatbots. One is GUI-based, another is WeChat-based, and I will demonstrate later. Here is an overview of the model. As you can see, the model is very complicated, but it can be divided into a few parts. The first part is the encoder and decoder framework. Generally speaking, they are just a gated recurrent unit. That is a variant from recurrent neural network, but these are 2 networks instead of 1, because their inputs and outputs are different. The encoder network will encode input into some hidden variables. For the decoder, it will take the output from the encoder as well as the type controller network, which decides the word type at each position of the output, as well as a hidden variable generated by the priori network. This hidden variable z is essentially a representative variable for the sentence function. It divides a two-dimensional space into a few subspaces to represent each sentence function. Discriminator network takes the hidden variable as its input. It generates sentence function. The recognition network and the priori network is essentially learning sentence function patterns from the sentence inputs. Specifically, recognition network is used for training, while the priori network is used for testing or, say, generating the response, even the post. Since their inputs are different, the recognition network takes both post and response, while the priori network only takes the post, and it will predict the z as well. So its log loss is taken as a KL divergence for this network. This network is built using the multilayer perceptron. So is the discriminator network as well as type controller network. But except for these two networks, the other 1, 2, 3, 4 networks are all using loss functions as their objective functions. Total objective functions for this model is a weighted summation for all the losses, and the type controller classifies word type at each position. We will use relevance score between the topic word and the post to evaluate most appropriate topic word for the output sentence. And for the training process, I will describe about our data. Here is the training post, and the total size for the training dataset is close to 2 million. Every sentence in the post corresponds to one response, and every response training set corresponds to a sentence function label. The final model setting is shown in this figure. The parameters and the number of hidden layers is displayed for every network in this screenshot. This is the evaluation part. This figure shows the total training accuracy for the training process within the first 1000 iterations. As you can see, within the first 200 or 400 steps, the accuracy converges at a certain level, and in the future, the learning rate is very slow. The reason for this is that the decoder accuracy, the networks related to generating informative results, as well as the type controller, which controls the topic words, their accuracy is not sufficient and usually less than 1%. However, the sentence function controlling network is already very good in the first 1000 or 2000 iterations. And at 2000, I remember its accuracy is around 97%. So these few charts indicate that it's very easy for our model to learn the sentence function feature, and it is also very easy for our model to generate response with respect to certain sentence function. But it is difficult for our model to generate informative response or topic-related response in this case. For the limitations, during the training process, we only use the CPU TensorFlow. The reason why we don't use the GPU TensorFlow is that the memory for the GPU is not enough to train the huge amount of parameters within this model, and it will pop up a fade error after the first few iterations. So in the future, we may improve our hardware, and it will demonstrate more prolific results. Besides, we only carry out one settings for the parameters. We don't compare the models with other models or other prevailing models. Our evaluation scheme is not sufficient to prove that our model's effectiveness, and we only carry out some cases to check whether the model works or not. So in the future, we may need to construct some prevailing models for comparisons. And at last, in this project, we only consider one-turn conversation. However, in practice, most of conversations need to refer to the context. We may need a model with multi-turn conversation feature. In summary, we build a conversation model with sentence function controlling and informative contents. Our dataset is retrieved from professor's webpage. The source codes are from GitHub. However, I made a few changes a few updates and also fixed bugs in the scripts, and also created 2 chatbot applications to implement the conversation model. Limitations and the future studies are also discussed at the end of this project. The training results and implementation cases indicate that the networks for controlling sentence function is already sufficient, but the networks for topic words and the informative content generation process still need to be improved in the future. Thanks for listening. Okay, in the next few minutes, I'm going to show you how to run the GUI-based chatbot and the WeChat-based chatbot. Okay, first you need to initiate. You need to go to the folder containing the file, containing the script. So in my computer is here, and then you simply run Python main GUI.py, and first it will take a few minutes to load the model and the training data, and we need to wait a few minutes. So I will skip here. Okay, at the same time, I also want to load the WeChat chatbot for preparation, and it's simply let me check. It's simply its name is just WeChat. Yes, just a Python main WeChat. And for WeChat chatbot, you will pump up QR code for you to scan. If you scan, then you will log into the web-based WeChat. After that, the messages sent from your friends can be received from the by this file, and it can generate response with our model. Okay, and there's some warnings. You just ignore them, because many functions will be depreciated in the future, and the TensorFlow is recently building a new version of them. And right now the GUI chatbot is ready, so you need to enter a sentence for testing. Okay. Let's say what a good weather. I want to go traveling. And the first sentence is kind of slow, but afterwards the testing will be very fast. Okay, the QR code is generated. I will I will scan with my WeChat. And then, as you can see, the login is success. The login is success. I will load. I will log in with another account for testing. And since you cannot see the result, okay, oh, you can see the result. Okay, first let's repeat this for WeChat. Models are the same. Uh-oh. Okay, it takes some time to proceed the first response, and actually it is a random number, random chosen from the 3 of them. And as you can see, the result sometimes is correct, and sometimes they are informative but not appropriate. And it is correct in grammar, but it is not commonly used in our practice. And for another example, let's try. The class is over. I'm resolved. As you can see, it's awkward to answer like, do you want to buy shoes, right? Or sometimes it is thanks for your support. It's nothing to do with the support, right? And imperative response, I think the classification for imperative response is not correct. Sometimes it is, I think they're just a declarative response, and this is also a problem. Yes, yes, do you think another example? Let's try, we are happy. I'm very happy. So as you can see, it's not relevant, but it is informative, right? And at back end, all the results, all the possible results, possible response will be printed in the backend. Yeah, I think that's all. Thank you.